We already have used the synchronized keyword to impose synchronization among threads. There we have locked various objects. But the synchronized keyword never does justice with a thread which is waiting since long. If you want to execute a thread which is waiting for the lock for the long time before a thread which is waiting for the lock for not that long time, in that case you need to use the ReentrantLock. Namaste everyone, I am Gyan and you are watching the session 20 of Java and Web, Multithreading in Java. With synchronized keyword, we were locking any type of object. We already have seen this concept in the earlier videos of this session. Let's use a special class in java.util.concurrent.locks package called ReentrantLock. So the class ReentrantLock is present in this package java.util.concurrent.locks. The ReentrantLock class is an implementation of lock interface. The lock interface itself belongs to the java.util.concurrent.locks package. Means these two, the class ReentrantLock and the lock interface, both belongs to this package java.util.concurrent.locks package. ReentrantLock class contains various lock specific methods. Therefore, the ReentrantLock class implements the lock interface and is a child of object class. There are two constructors for the class ReentrantLock. One is the default constructor and other one is the parameterized constructor which accepts boolean as its argument. Using this default constructor causes a random thread to get the lock, and using the default constructor of ReentrantLock is similar case of synchronized keyword. But if we talk about the parameterized constructor of the ReentrantLock, then if the boolean argument is true, then the longest waiting thread will acquire the lock first, and if the boolean argument is false, then it causes the random thread to get the lock. And this is similar as this default constructor. Passing here false is similar to using this default constructor, and using this default constructor is similar to using the synchronized keyword. So let's understand the ReentrantLock. Before to that, let's create a program without lock. Here we have two Java files, mythread.java and check.java. In check.java we have the class check, in the class check we have the method main. In the method main we are creating two threads. Name of first thread is T1 and name of the second thread is T2. Then after we are starting these two threads. Both threads are created by using the class mythread. The class mythread extends the class thread. The class mythread have the method run. In the method run, the thread is going through the loop from 0 to 5, and for every iteration the thread is sleeping for half seconds, means 500 milliseconds. After that we are printing the name of the thread and value of I, the current value of I. So both threads will execute this run method, and since we are not providing any lock, so any thread can get a chance on the CPU. Therefore the output will be very unpredictable. We already have seen this type of program in the previous videos of this session. Let me execute this code practically. Open mythread.java, and this is the same code as we have seen. Open check.java, and this is the same code as we have seen. Try to compile these two codes, java c, mythread.java, check.java, compiles fine. Now run it, java check. It runs fine and printing a random output. Now we are all set to use the ReentrantLock. In the check.java we have the class check. In the class check we have the method main. In the method main we are creating a new object of type ReentrantLock, and of course we need to import the ReentrantLock from the package java.util.concurrent.locks. While creating the two threads, the same reference will be passed to both the threads, and that reference will be stored into the reference variable L, the instance variable L of class mythread. So two threads are now working on the same object, the same ReentrantLock object. By using the reference variable L, we can call the lock method, and the thread which executes this lock method first, that thread will be able to execute this for loop. After doing its work, the thread who got the lock first will unlock the reentrant object. Then after, the other thread will try to get the lock. So this example is similar to whatever we seen with the synchronized keyword. But in this case, since locking mechanism is used, That's why we will get the ordered output. Because if T1 gets the lock, then the T2 cannot enter in this area before the T1 calls the unlock method. So let's try this code practically. Open mythread.java, and this is the same code as we have seen. Open check.java, and this is the same code as we have seen. Try to compile these two codes. Java C, mythread.java, check.java, compiles fine. Now run it. Java check. It runs fine, but at this time the output is organized. The T2 got the lock first, therefore the thread T2 executes all the iterations of the loop. After when T2 calls the l.unlock method, then only the T1 is able to call l.lock method. If I execute this code once again, then T1 may get the first chance. Not at this time. Yes, at this time T1 got the first chance to execute. Let's do some experiment on the code. Open mythread.java, and instead of calling the lock method only once, let's call the lock method twice. l.lock. Now whoever gets the first lock, that thread will get the another lock, and at last that thread is executing the unlock method only once. So you can see here the lock method has been called twice, but unlock method has been called just once. If you are calling the lock method twice, then you have to call the unlock method twice. Otherwise, the thread which got the lock will never unlock the reentrant object. So give a semicolon and try to execute this code. Of course, the code is going to be hanged. T2 got the chance, but T1 will never get any chance, because the T2 is not going to unlock the reentrant object for the second time. Let's execute it once again. T2 get the chance, but T1 will not get the chance. Let's open mythread.java once again and unlock it twice. Call the unlock method twice. l.unlock. Give a semicolon. Try to compile these two codes. Compile fine. Now run it. It runs fine, and at this time the code will execute fine. One thing I want to say you, if I open check.java, then we can create the reentrant lock object by using true as its argument. We know that the same reference has been passed to two threads. So here we are creating a reentrant lock object by using true as its argument. So what will happen? If a thread wants to get a lock, in that case, that thread will allow to get the lock which has longest waiting time for the lock. So you can use here true or false. True means give the chance to that thread which is waiting for the lock for longest waiting time. Now compile these two codes. Compiles fine. Now run it. It runs fine and executing everything perfect. So I hope you got all my points. That's all for this video, guys. Don't forget to like and share.